Good morning, everyone. I'm going to try to fire this up on the batteries. I got two D cells here. These have never been used, from the Dollar Tree. They're a couple years old, I guess. They read 1.529 volts, both of them, unloaded. Of course, when you use a meter on them, they're going to read higher than what they, are if you use a 1,000 ohm per volt meter or when they're loaded up on in the circuit. Because this is strictly battery, there's only one 10 microfarad or 8 microfarad actually electrolytic in this. There's no harm in trying this out to see if we get any life at all out of it. Now, I don't have a power supply. They haven't made it because I don't want it made a certain way. So I'm going to use the EICO 950. I'm going to set the voltage to 67.5 volts or thereabouts, 68 volts. But I'm going to put a big filter capacitor across the output of the EICO 950. And that way it'll make sure it's a good clean DC. I'll find a nice fat electrolytic, get the voltage up to 67, 68 volts, and then connect it to here. And then when you open the door on the radio should turn on. I have not tried this because it's in such beautiful condition. I'm going to assume that there's possibility that the tubes are good. It's a SOB getting the tubes out, especially this one right here. So I do have some service information on this. But all I'm going to do today is try it out. This is a show and tell. It's about 45 degrees outside now, today being Monday. Quite a difference from Friday night and Saturday. Ooh, boy. So let's get you on a tripod here. We're going to get things hooked up with the EICO 950 and get the filter capacitor across the output of the 950, which is leads are right here for the output. We'll get all this hooked up. We'll turn this off for now. And we'll be right back. The first thing I want to do here is these are copper. I guess you can see that. These are copper here for the D cell. The positive is down. So I use a pencil eraser to clean off the contact. So I don't think you can see it with my hands in the way, but I got to work where I can see. That's vitally important that I see. So we clean the contacts. These are copper, as I said, and I don't want to sand them. I don't think they're that bad. There's not enough light. I'm in my own shadow, but that's nothing new. I know I don't have good lighting for videoing in here. So we'll do the best I can. This one isn't too bad. So, and let's make sure that the batteries are okay, which they are. Now, all right, so I'm going to have to move the camera. There's your contact right there, your negative. And You're positive. Now, I put that plus on there. All right. Well, the high capacity, anything over this is 680 microfarads at 100 volts, so that would be fine, but I've got 2200 microfarads, but they're only 50 volts, so we're feeding in 68 volts. So what we're going to do is put these two in parallel. These are new. We're going to do all that off camera. We're going to have some clip leads going to the battery, the B battery connector on the radio. And we'll have the voltage preset to 68 volts, so we've got to get the meter over here too. And you notice I moved the Crosley out of here right now. Also, of course, I printed out the schematic of the Crosley as well as this radio. And I have 2 copies of each. So anyways, we're going to go put this on, and I'll be right back. Sorry about the handheld, but I have to do the best I can here. All right, I got the 2 electrolytics in parallel, but I don't have the voltage coming into them yet. On the meter now, with the EICO 950, let me just get that up there a little bit. That's a damn glare, I think you can see that. I had to get my magnifier on the viewfinder of the camera. All right, the EICO 950 is turned all the way down. It puts out 38 volts. So what we got to do is to set this up to 68 volts on the EICO here, and we're going to do that now. There's no capacitor on this yet, and it's not connected to the radio because you can see how fast it shoots up. Need a vernier dial on this. I really need to make a power supply, but it's going to be unregulated anyway, so it's 69 volts. All right, this is without the capacitors on. We're getting 68.1. Sorry, I got to get my face on there. I can't see nothing without it, even though I got my reading glasses on. The radio is not connected. The A battery's not connected. I got to get this voltage established. So what I got to do now is to bring a clip lead. I got the negatives on the meter to the negatives of the capacitor and the negative of the EICO. Okay, I'm talking too loud again. I'm always doing that. But I don't have the positive connected to the capacitors. I do have the positive connected to the meter. Obviously, you wouldn't be seeing it, and the EICO. So I got to bring a positive lead over to the meter. So we're going to get another clip lead here. And we're going to go, I got the positives paralleled, so we just go to the positive. You can't see what I'm doing here. I can't do picture-in-picture like a lot of you can do, so you're going to have to rely on my word. So we're going to touch the capacitors briefly. It's going to bring the reading down. Now, the damn clip lead came off because I can't see it. I got to get my face right on it. I'm sorry. I can't see. I'm as blind as a bat. So frustrating. Okay, now we're letting the capacitors form up. These are brand new 100-volt capacitors. We're putting under 100 volts on them. Only 23 volts. The EICO, you got to remember that the EICO 950 or even the Sprague Telemic, they put out high voltage, but they put out very low current. Now, I assume, you know what they say about the word assume. My wife is always saying it makes an ass out of you and me. I assume that the radio, I really don't know what the current draw is on the B battery, but it can't be very much. I'm estimating maybe 10 milliamperes. because those batteries, the original battery, which goes in this radio, which is an Eveready 467, stone dead. This came with one of my radios. This wouldn't last 2 minutes in there if it was drawing 30 or 40 mils. So most of your current is drawn off on the filament battery, okay? So we're going to let this form up. And like I say, this is just a test to see if it'll work. Now, I got such a Rube Goldberg of wires down here. I've always done this. I've always Rube Goldberg things. I don't like using those breadboard things, those white things where you push the wires in. I don't like that kind of stuff. I like something where I can trace out the wires and, you know, I'm from the old school. So we're going to let this climb because with the batteries, I guess you can see that, yeah. With the batteries, I mean the capacitors rather, 50 volts now, you don't want this to surge up too high. Obviously, it's like I say, a very low current. High voltage. When I do make my power supply, I may figure out a way of making it so it could operate the B voltage on these radios too, but that's going to be a while. Like I say, I'm from the old school. It's got to be a metal cabinet, it's got to be a vintage cabinet, and that's the way it's going to be. It's not going to be a plastic Chinese-looking thing. It's all right for modern stuff, but I like working with vintage equipment. Of course, this isn't vintage. Things like this I don't have a problem with, but when I want my test gear, I want my test gear to be vintage, with the exception of, you know, a few pieces that are good to be modern, you know. She's climbing, but I want to make sure this isn't going to climb up over 68 volts, you know. So I'm using my second JVC camera, which sometimes will distort if I talk too loud on the audio. I've only paid $20 for this at a thrift store a couple years ago, probably even be longer than that. This is the Model 30. I don't remember the lettering prefix before that, but the one I usually use looks identical to this, but it's a little better quality video, is a Model 100. It's being charged over there. Let me see. Maybe I can read it. What the model of it? Yeah, a GZE100BU. That's the camera I normally use, the JVC that I normally use. This is the 30, and whatever the prefix letters are. I can't very well read that because I'm using this camera now. So we're up to 67. We're going to make sure that it doesn't go to 75 or 80. You don't want to really feed the radio too much B voltage, although a lot of these radios I've had years ago, they take 90 volt batteries. You know, I always loved to get one that I had in 1959 when I was in New Haven. No idea where I got it from. There was no eBay back then. Certainly didn't buy it online. There was no online back then in those good old days. It was 63 volts. It might not climb anymore. The capacitors may be it. This EICO might not deliver it, and I'd be very surprised if the EICO is not able to supply the current needed to run the battery radio, which those 67.5 volt batteries that I just showed you, they don't deliver a lot of current because it'd be dead in no time. And they were quite expensive then. But anyways, the first radio I got, battery set, I don't know the name of it. I don't know whether it was an RCA, an Emerson, but it used a long, skinny 45 volt B battery, and I don't remember what it used for an A battery. Don't think it was a D cell. It was something else. And it used those flat hearing aid tubes. They look like the same type of tubes that are used in the high voltage doubling circuit of a Tektronix 535 oscilloscope, of which I had 2 of them years ago. So I'd love to get my hands on it, but I have never seen one on eBay. Never. All those battery sets all use the 7-pin miniature 1.4 volt tubes. But this one used the flat hearing aid tubes. The tube is flat and the pins come out straight out of it, little wire pins, and they plugged into sockets. And the radio was tiny. I must have threw that out years ago. I had 2 or 3 different battery radios in the late 50s and very, very early 60s. Kind of wished I hung on to them. All right, it don't look like we're going any higher. So I think we better push up the EICO. These capacitors, we got to push the EICO up because we got to get it up to 68 volts. Now, I can tell you right now, when I put the load on, when the radio comes on, it is probably going to be pulled right down. Now, there's no guarantee that the radio is going to work, but I did want to make this video. And what I'm going to do, I got to get 2 more clip leads, one for the negative, one for the positive. And I'm not in camera, I know that. But you can see my hand here. Let me bring the radio over. What I'm going to do is to open the cover, because that's a switch. You open the cover on the radio, and it turns the radio on. I'm going to hook the B plus up to here without the A battery, and that should tell me if there's a short in the B plus circuit. The A battery, which I'm going to be using these, and you really should be using alkaline, but I don't think they had alkalines back in the 40s and 50s. I doubt it, because they're just general carbon zinc cells. That's what they used. Where's 73? I don't think we'll do any harm putting 73 volts into that radio, because these adapters that you can build for these type of radios, they're not accurate. They could put out 90 volts unloaded, even though the tap on them may say 67.5. But I don't do enough of this stuff to warrant anything like that. So what I'm going to do now is I'm going to stop the video. I got to get wires hooked up from the 74 volts now, but it's going to pull down. Now, I tried using the EICO in the past on other radios that I've worked on of this type, and it pulled the voltage down to the 30s, so there's no way. And if that's the case, we have to end our test at this point. I can't imagine these radios drawing more than 10 milliamperes of B current. All right, so let me stop it right now, and I'll be right back. I got to hook up the B supply from this conglomeration. I got to go in here and pick up the B supply and feed it to here. And you notice that I marked this so I don't screw up. I put a plus in there because the female part on the socket is positive, where the male is positive on the battery itself. So we'll go do that. We're going to get it all hooked up. And then on camera, I'm going to try to show you touching it on here. We'll probably leave the positive on and disconnect the negative. Doesn't matter what one you do. But before we can do that, we got to open the case up on this radio so it'll effectively be turned on. I'll be right back. I talk too much, don't I? All right, I'll try to be as steady as I can because I got the mini tripod on the camera, so it's a little awkward. All right, what I got here is the positive and the negative connected. The positive is connected to the electrolytics, and it's safer and easier for me to apply the negative, okay, to here. Now, you're not going to be able to see me do this, so take my word for it. I can't do picture-in-picture like a lot of you can do. So I'm going to set it up, and you can watch the meter. And I'll go my magnifying glass and look on the screen here, and we're 77 volts. So I'm not going to worry about it, because as soon as I connect this up, the voltage will probably go way down. So let's connect it. In fact, it's going down instead of forming that capacitor up that's in there. 48, but we'll give it a chance. It's 50. All right, I'm looking at this sideways, so I can't see it exactly. But let it climb up. And we'll see. As far as I can tell, the only harm that'll happen is the 100 volt, 8 microfarad electrolytic. There's only one in here. Could break down. So we'll let that form up. Get you over here. So I got the negative. The negatives are tied together, so you got 680 microfarads in parallel, two of them. The capacitors are rated for 100 volts. And there's no A battery in here. I think the volume's all the way up. The cover's open, so that's the switch on the front, which I showed you on the video I made when I first got the radio. And we're going to let it climb, and it's looking very good. So we're going to let that capacitor form up in there. May take a little video time, but you've got time, don't you? If you got the money, honey, I got the time. Will music? Well, never mind. All right, what are we? 64 volts. We'll let it form up. Now, if the radio's functioning, we put the A battery on, there's going to be current there on the B+, because the tubes will be conducting. We don't know if all the tubes are good, but this is not going to be working on it today. This is just a video to see if there's any life in it. Normally, if this had been an AC-DC radio, in other words, like the ones I've been working on, like the other Motorola's that I've had, well, this is not a Motorola, but like the Motorola's, they were battery and AC, of which I converted them strictly to AC, and I converted the switchover on those two radios, which I made a video about, switching both the hot and the neutral at the same time. So you really did not need a polarized plug, because no matter what way the plug went into the wall, they were both turned off anyways. Well, actually, it really is better if the chassis is on the neutral anyways, so you don't get as much interference. All right, so we're 68 volts now. What I'm going to do now, I have no idea if it's going to work at all. I'm going to try to get this into the radio. You keep an eye on the meter, and I will try to get this A battery in here. Which does not want to go in. It's in. Oh yeah. It's conducting all right, but now what is it, 37, 36 volts? So you're not going to get anything out of the radio at 36 volts on the B+. So there's possibility we could have some bad tubes, leaky coupling capacitor to the audio output, which is a 0.002, but it could be a disc capacitor, which they very rarely go bad, especially on these low voltages like this. She's only 37 volts, and I'm not going to push the EICO up anymore because now, in closing, I think we're going to end this video because we are not getting anything. I'm holding this battery in. It wants to pop out. I really need to get this radio. I got a soft mat there, so I need to close the cover off camera and try to push this battery down so I don't have to hold it in there. I don't want to force it and break something. That's me, you know, I break things very easily, especially plastic. Something don't move and I get too rambunctious and bust it. And I don't want to bust that grill trying to push this D battery in here. But, yeah, you're not going to get anything out of that. Yeah, the battery does not. You're getting static. Let me try to. Might work if I can get more B+. I can't imagine this thing sucking down the power supply of an EICO 950 B. Oh, that's my finger. That's my finger doing that. I thought that was static in the radio. I'm trying to tune the tuning capacitor, which turns very hard. No, there's no dial cord, Ron. Isn't that great news? Oh yeah, there is static when I move the battery. It's very awkward. Let's see if I can. Well, 27. I'm going to push up the EICO. It can't possibly hurt it. It just might not put out the current. But the problem is if the A battery disconnects, I'm pushing the EICO up. If the A battery disconnects, we'll let it climb now by itself. I don't know where it's... then you got well over 100 volts or more going into the radio when you're going to pop that electrolytic. So it's not a good thing to do. Because the A battery's in here, this radio's drawing current off to B+, which is what it's supposed to do, but now the only noise I get out of it is when I move that A battery. I don't expect it to work, but it's very disappointing that this thing draws so much off the EICO 950, and just push it up a little more, and that's the end of it. I'm not going to turn it up anymore. I'm putting in, according to the dial on the EICO 950, 200 volts. But that dial is way off. Way off. I think it actually puts out less. But it's over the rating of that electrolytic that's in here. So 39 volts, you're not going to get it. It just can't deliver the B battery. So maybe these radios draw, I don't know. If anybody's got an idea, flash it out on the comments. What does the B battery, in other words, what does the current of such a radio on the B+, how much current does a radio draw? Is it 40, 50, 100 mils? I can't measure this because my EICO 950 does not supply the current. After all, it's only for testing electrolytics and other capacitors for breakdown voltage. It's current limited by a resistor in the EICO. So, now, I'm afraid we can't do it. So, and we're going to prove it by turning off the EICO. We're not going to turn down the voltage control because that shorts the voltage to ground, and it's not good for that potentiometer. That's how a lot of the voltage controls get burned out in your EICO 950s, because the guys would turn them down, and you shouldn't do that. What you should do is bleed it off or turn off the EICO and then slowly turn it down. So you're not going to ruin the potentiometer. So we're going to turn off the EICO. And I just turned it off now. Now it let it bleed off by itself. And we'll take the battery out of the radio. So, what we're reading now is the discharge of these electrolytics, and we'll take it off the radio. We'll turn off the meter. All right. Well, I can't imagine these radios drawing more than 10 mils off the B battery. On the A battery, yes, whatever those tubes are draw, they're all in parallel. Remember, this thing has got 1.5 volt D cell in here, So I looked at the schematic and I knew very well that all the I can't even talk this morning. All the tubes are in parallel, including the 3S4. There's a tap on the 3S4, and it's a 3-volt tube, but it also could run on 1.5 volts, and that's the way it's wired in this radio. So the current of 4 of these type tubes in parallel will draw quite a bit off the A battery. Now, I didn't measure the voltage drop of the A battery. I could do that. I could put clips on here, but we're not going to do that because we can't get enough current on the B circuit from my EICO. I just can't. And at this time, I can't build a power supply. All it's going to be is a brute force power supply. I can't build these complicated things, and I don't want to. I'm always looking for something that on eBay, but the prices are out of range for me, but I don't have the room for anything. But if I can get something small, vintage, that would go from 0 to 450 volts, that'll deliver enough current for the average tube radio that runs on AC, and also will give me enough current at the 67.5 or 90 volts on the lower end. Probably have 2 settings, one 0 to 90 volts, and another, and to switch it over, and 0 to 450 volts. The 450 volts probably would be less current. Maybe there's 50 or 100 milliamps is drawn on this, which case the EICO will never be able to do it. I don't know. I have no way of finding out what the current rating is. The only way I would know is to have a power supply that could deliver, and then I could put a milliamp meter in series on the B line. Okay? All right. I think I've talked enough. I think I gave you enough entertainment for today. I hope so. So we'll get this video out to you so you'll have something to be bored with. Thanks for watching, folks. And remember, this does not get worked on until the springtime.